Welcome, everyone, to today's session. My name is Oscar Martinez, and I am the head of the Big Data Cloud and Advanced Analytics in ClearPeaks within the Simber Group. And today with me, I have the honor to have Leo Avalos, who is one of the data scientists in my team. Today, we are here to talk about SharePoint Lens. SharePoint Lens is the outdoors name that we use for a tool that we also use internally. Internally, we use SharePoint Lens, but we call it InnoHub, okay? So first, we're going to introduce what's SharePoint Lens, or InnoHub, as we call it internally. And then, as you will see in the introduction, it's basically a tool that complements several Azure and Microsoft services, and today we're going to put the focus on the AI ones. So we're going to be focusing a bit on the Azure AI Search service. Then we're going to be covering how we deal with answer generation, how we basically manage to get answers from the Azure AI service. We're also going to be covering how we basically generate metadata that we store for SharePoint Lens, and we're going to do finally a demo, and we're going to conclude with a wrap-up and conclusions. Let's get started with the introduction. Before we dive into SharePoint Lens, let us first begin with who we are, right? So we are ClearPeaks. ClearPeaks is part of Simber, and Simber is basically the joint effort of 7 successful firms around data. We started in Europe, but we are growing quickly to cover also other regions, and we have offices now in many different places, as you can see on the map. We are one of the 7 companies. The rest of the companies in the group are Data Divers, Data Insight, Data Focus, Syracuse, TCM, and XKicks. And all of us basically work around data projects for our customers. In our case, in ClearPeaks, we basically focus on the 5 areas that you see on the top. We do business intelligence projects. We do big data and cloud projects, advanced analytics, executive web and mobile experiences, and also data governance and strategy in general. Today, our project or our presentation will be more around the advanced analytics area. So we're going to be covering this. Simber, combining all the different firms that we have in the group, we are talking about more than 500 consultants with more than 1,000 successful projects over the last 20 years. We have more than 250 customers spread through a lot of locations and a lot of countries. That said, today, as I said, from the different areas that we focus on today, we're focusing more on the AI part. So we can be your AI partner. Our consultant services around AI basically can be split in these 6 categories. We can help you with discovery and strategic initial steps of your AI journey. We can also help you in, let's say, maybe the second steps, which is, AI is important, how we bring adoption into your organization, how we can help you lead these AI efforts. So those are also the second step that you can do. And then we can basically work in different AI projects, from traditional AI implementations, traditional ML use cases, to more, in the recent times, all the Gen AI about LLMs, about RAGs. So all these topics are topics that we are helping already our customers for the last few years. And we've also been helping customers with basically enabling automations based on AI, what we call the AI ops. So that's something that we can also help. And finally, the last area that I could cover is basically the ML ops, and ensuring that your ML projects are not just POCs, but they are properly put in production with all the best practices that should go with that. In the spectrum of AI, we basically deal with many different technologies. But today, the ones that we're going to focus are Azure, OpenAI, and Python. And today, SharePoint Lens, which now we're going to start talking about SharePoint Lens, is basically the part of SharePoint Lens that we want to talk revolves around Gen AI. Okay, so what's SharePoint Lens? You, as a member of your organization, for sure, have knowledge stored in some knowledge store. This can be OneDrive, but in many places, it's about SharePoint. You have your data in SharePoint. And we, in ClearPeaks, we are no different. We actually store a lot of information in SharePoint. We store information about our completed projects, about what things we did well, what things the customer benefited from our projects. We also, as you can see in our blog, we also write and contribute to the community with a lot of knowledge from our technical developments, which are publicly available for anyone to check. Also internally in ClearPeaks, we do a lot of sharing, knowledge sharing, and basically we do prepare sharing sessions internally where we explain each other our projects. And I'm sure that similarly, other organizations have the same concepts. No, they basically have an internal store of documents, and these documents can be very varied depending on the organization. No, in our case, in ClearPeaks, these documents are related about our projects and our successes. But in your organization, this might be very, very different. So normally, we've been traditionally using the SharePoint user interfaces. No, you go to the web browser, or maybe you have SharePoint synchronized in your desktop or Windows machine, and you basically navigate like you do with a file browser, but just on the web UI. And that works fine, no? But imagine that we basically start bringing AI into the picture, and wouldn't it be great that we could leverage AI to basically find the content within our store of knowledge in a faster way? So this is basically what SharePoint Lens does for you. SharePoint Lens is not, by the way, a product that we started recently. SharePoint Lens is the evolution of a previous product that we were already using internally, and that we actually wrote a couple of blog articles, which we call it, initially we call it Advanced SharePoint Indexer. And the Advanced SharePoint Indexer basically started like, let's basically tag the data that is in SharePoint using SharePoint columns. And then basically we tag the documents properly, and then we build a nice Power BI interface for interacting with the documents. And that was the basis of SharePoint Lens. It still uses that. What we basically did recently, and now I will move it to Leo to go into the technical details on how we do it. We basically brought AI. We brought generative AI with LLMs, with RAG. All these concepts that Leo will now explain is what allow us to basically boost our old SharePoint indexer into what we now call SharePoint Lens, which brings not only intuitive user interface powered by Power BI, but also advanced filtering, which already was there. And now SharePoint functionality, the chatbot, you can ask questions to the store and it will compile and give you an answer, basically summarizing the information that the store contains. And this, of course, will reduce dramatically the amount of time that you spend searching for the appropriate content. It will give you the information summarized, so you don't have to scan through thousands of possible pages of information. We still leverage metadata on the documents. And what we're also doing as part of the SharePoint Lens and internally, like I said, it's in the hub. We're defining how we what standards we set for data quality. And then basically with this, we can ensure that the information that you get is properly curated and it's kind of proofed. Okay, so those are all mechanisms that we are bringing in. And as I said, we've been using it for a while, the Advanced SharePoint Indexer first, and now the SharePoint Lens, and internally it's in the hub. And we believe that this same concept and the same technology could be used and of interest of many other organizations that have also the same type of request. So without further ado, I'll now stop my part, and Leo, feel free to continue.
Thanks, Oscar. So now that we have a bit of an overview of what SharePoint Lens is, we'll delve a bit more into the technical details. What you see here is a diagram representing the entire indexing process end-to-end. And it starts, of course, with people uploading their documents, as usual would, except this time they get the option to add a few tags. This is stuff like which customers are involved, which technology they use, employees have worked on it, and so on. And if they're uploaded into one of these 4 folders, we have an ETL that will pick up the changes and perform some metadata extraction on it. This is what Oscar mentioned earlier. The changes are then uploaded to this data warehouse, and this is then used by the SharePoint Lens portal, which is the index, and the chatbot to serve results back to the user. We will focus on these two areas, so the chatbot and the ETL. And in the end, we will show a demo to showcase the final product in action. Let's start. Starting off with the chatbot. It uses a retrieval augmented generation architecture. This is a term that's been used a lot recently. It's a bit trendy, and that's because if you want to build a chatbot that is capable of answering questions that are about private data, so stuff that is not open to the public, it's the only option you really have. And especially if you want to add citations to the answer, so you want the answer to have citations to each individual document that is used, this is only possible with this architecture. This diagram showcases how something like this looks. It starts off by user submitting a question, obviously. The question is passed onto the search engine, which sifts through your own documents to pick out what it considers to be documents relevant to answering your question. The documents and the question are both passed onto the large language model, which generates an answer. This is then forwarded back to the UI. It formats it, makes it look pretty, and gives it back to the user. So we need four things. One, some kind of UI, a search engine, a document database, and a large language model. In our case, we decided to go with Azure Services for everything. For the search engine and the search index, we went with Azure AI Search, which used to be called Azure Cognitive Search, so you might know it as that, but it's the same service. For the large language model, we went with GPT-4o. And for the web application, we went with Streamlit, hosted on an Azure Web App Service. We used to use GPT 3.5, but we saw that it wasn't reliable. It hallucinated a lot and just confused topics constantly. So we ditched it and went with the more expensive route, but it was a lot better. In order to talk about some of the features we've implemented for SharePoint Lens, I want to first talk about Azure AI Search for a bit. It's a search service provided by Azure that allows you to create a search index with completely customizable fields. And with fields, I mean stuff like the title of a document, or maybe its content, or its URL, or whatever you want. And then you can use these fields to obviously search through them, but also to filter them or sort them, and also add custom weights to each field to alter the order in which your documents appear. When I say filtering, what I mean is you can remove search results based on certain conditions you may have set. You can, for example, require that the title of a document or its content contains certain words. If you use tags with your documents, you can then filter by tags. And then you can, of course, stack these conditions one top of another, so the search results fulfill multiple conditions at once. One thing we have implemented with this is filtering based on security groups. We have one field that contains which security groups are allowed to see which documents. And then when you use the application in real time, your security group is taken and is used to filter through the documents, so you only see what you're allowed to see. And this is both implemented in the chatbot and the in-app portal. What you see here is the search index creation menu. As you can see, we have some of our fields listed out. It's not all of them, but you can create as many as you want and then set what you can do with them with these settings. Retrievable means that it's visible to the end user when the search results are returned. In our case, it doesn't matter, so we set it to all of them because we don't really care. But we also have stuff like the filtering, the sorting, and the searching. The searching field in particular means that when you perform a search, that field will have an impact in the order of documents that you get back. This is done via a scoring system that assigns a score to each document that ranges from 0 to 4. And then when you perform a search, the top X results are returned. In our case, we set it to 20, but you can put as many as you want. And that means that the top 20 results with the highest score are returned to you. The score is compiled by two metrics, starting by this. The first metric is simply keyword matching. That means that when you submit a question, the words in your question are then looked through in the fields that you set as searchable. And if there's a word match between your question and the field, that document will get a score boost. For example, if you submit a question about topic A, and then in one document it talks about topic A in the title, and the title is set as searchable, that document will get a score boost. You can then also set custom weights to the fields. This means that you can set one field as more important than another one. And in our case, we set it so that the tags have a score boost. So when you submit a question that contains a keyword that is a tag in one document, the document will get a higher score. The second metric is a bit more complicated, and it uses similarity metrics. So it compares the similarity between one sentence and another. The idea behind it is that if the content of a document is similar to the question that you submitted, it means that it probably covers similar topics, and probably the document is relevant to answering your question. We calculate the similarity using sentence embedding models, and these are machine learning models that are used to turn plain text into numerical vectors. These vectors encode the meaning of the sentences. So then if you compare two vectors mathematically using a metric like cosine similarity or the Euclidean distance, you can then determine how similar two sentences are. In our case, we use cosine similarity to calculate the similarity between vectors, which is the equation that's shown here. But other metrics are also fine. It doesn't make that much of a difference. But in any case, this is the final diagram of the entire document retrieval process. So you have the user that submits a prompt. This is then turned into a vector, and alongside the security group, all of this is used by Azure AI Search to get the documents and return them back to you. And now we move on to the second part, which is answer generation. As was mentioned earlier, the answer generation is done by OpenAI, specifically GPT-4o, which is one of the latest models they released. You can pause to read the prompt if you want, but to summarize, it includes the question submitted by the user, the 20 sources that were provided by the search engine, then some instructions. After that, it instructs the prompt to add citations to the answers, and then it gives an example of a correct answer. You can see a generated response here. So as you can see, it splits up the response in paragraphs, one for each source, and then it cites each source in the end. Since this is a large language model, there's obviously the risk of incorrect information being generated. This takes on two main risks. The first one is that since the knowledge of the response is limited to the documents that get brought up by the search engine, and they are limited to 20 search results, if something ranks in position 21, it will be omitted. So that's as if it didn't exist. And the second risk is that the LLM just hallucinates something up, although that's pretty rare. What's more common is that sometimes it might confuse a topic with another one if they are very similar. So if you have a question that's very important, you should check that it's not confusing anything with anything else. So with that in mind, this is the expanded diagram. So the user submits the question with the security group. The search engine does its stuff and retrieves the documents. Then the prompt is constructed and gets sent to OpenAI, and the answer is generated. Now let's move on to the metadata generation part. Every day at 4 a.m., an Azure function gets called that lists out all of the new documents that got uploaded, and then for each one generates a summary using GPT-4o, and then generates the tags for the technology, domain, industry, and functional categories. There's other categories like the employee tag, but since this is not something that is contained within the document, we don't generate it automatically. The summary part is very simple. It's just we ask GPT-4o for a summary that's between 100 and 150 words long. We also ask it to add a timestamp at the beginning of the summary. So if in the document somewhere it mentions when the document was created, it gets added as a timestamp at the start. And then it also asks for the summary to be in English. This is, for example, if a document is in German, because we have German companies at Simbert, the summary is in English nevertheless. For 3 out of the 4 tag categories, we also use GPT-4o. And that's because as there are only like 5 or 6 different tags for each category to choose from, we can just present the document to GPT-4o, list out the tags, and ask it to pick one. With the technology tag, this isn't really possible because instead of 5 or 6, there's over 300 options to choose from. The technology tag is used for listing out which technologies were used in the project. So there's way too many options, and when you ask GPT-4o to do this, it often makes up tags that don't exist, and it also lists way too many that are not useful. So it's not a viable option for this particular use case. Instead, we have to analyze the text of the document. The first thing we do is, obviously, if the tag is present in the document, it gets listed as a tag. So if you talk about Oracle something in the document, it's going to pick out the tag and associate it. But the problem with this is that it's not always written the same way. So the example I show here is with Amazon S3. You could write out the same service as Amazon S3 or AWS 3 or just S3, and it applies to the same concept. But if you just search for the tag in the text, all these three are not going to show up because it's not written exactly in the same way. So to mitigate this, we make use of named entity recognition models, which, as you can see in this example, they are models that specialize in detecting named entities. For example, here it detects Apple as a organization, today as a date, the iPhone SE as a product, and so on. And so what we do is we scan the text for named entities that are either technologies or corporations or anything that's a branded name. And then we take those as candidates for tags. We then compare those candidates with the real tags, with the similarity metric that I mentioned earlier. And if they are very similar, we then choose that tag as a final tag for the tagging. Okay, so with this in mind, this is the final diagram that represents the metadata generation. So we start off with the Azure function listing of the new or modified documents. This then passed on to the named entity recognition model, which generates the technology tags. Then with GPT-4o, on one hand, we generate the remaining tags, and on the other hand, we generate the summary. This is then stored alongside the embedding vector of the summary. All of this is then fed into the Azure AI Search service, and this is then used by the chatbot to serve results back to the user. Okay, so this is the UI for the SharePoint Lens chatbot web application. As you can see, there's a text field here to introduce your questions. So let's ask something simple like, what experience does ClearPeaks have with IoT stuff? This will unfold two panels. On the left-hand side, we have the search results that are provided by the Azure Search Service. And for each document, we have the title, the document, so a hot link, the company that it corresponds to, because again, we can filter by company, and then a timestamp and a summary. As you can see, it shows the first 20 results. This is then used all at once to generate the answer. So two of the documents correspond to the answer. So it generates them, it cites the sources, and then at the end, it also links the documents. At the bottom, there's a follow-up question field where you can ask follow-up questions to either ask for clarification or to reformat your answer. So in this case, we'll ask something like, please rewrite this as if it was an email to your manager. It will then use the first answer to generate the second one. And as you can see, it gives you a template with the same information, just with the format change. You can also ask to shorten it. And let's say it's too long. Make it shorter. So we will get the same answer as before, but shorter. In the end, since this is plugged into ChatGPT, you can really do anything you would ask ChatGPT as well. For example, let's say after answering this, draw not that this would be any use, but it can be done. It will try at least. So yeah, that's the demo. Okay, so to wrap things up and conclude things, in this video we introduced you to SharePoint Lens and the chatbot. We give an overview on how modern chatbots work and how our particular implementation was done. After that, we explained how the metadata generation routine works and how we implemented it. And then finally, we showed a live demo of the chatbot in action. If you found this interesting, we have more webinars in this YouTube channel, and we also have blogs in the ClearPeaks blog at clearpeaks.com. And yeah, that's it. Thank you.